So today we're going to learn about other ways of measuring spread and dispersion. Spread and dispersion, apart from mean, median, and mode, we could also use range, interquartile range, variance, and standard deviation. Today we're going to cover range and interquartile range. Range is defined as max minus minimum, so the maximum, the largest number in your data set, minus the smallest minimum number. In terms of reliability, this is unreliable, right? So this is kind of like the mean that we talked about last time, where you're using maximum and minimum values. So just like the mean, the extreme values, max and min extreme values, would affect the mean value. So what we do is we instead use the interquartile range. This one is the more preferred. This is also known as IQR. IQR means quartile 3 minus quartile 1. This is more reliable because you're only using essentially the middle data points of your entire data set. So it's more resistant. Kind of like median, but gives you a better idea of spread and dispersion. So as you can see, for example, there are A, B, and C bell curves, and with each of these curves, you could set a lower quartile, which is Q1, and an upper quartile, which is Q3. This means that the mean, which is the average, right? Towards the left, you have the lower quartile, the 25%, and then you have the 75%. So in order for us to find the IQR, we find essentially the IQR of the in-between values, so between the Q1 and the Q3. So that takes away the extreme values. Range and IQR, an example, so suppose you have this data set. The range would be the maximum, 9, minus the minimum, 1. That gives us 8. Here, if we cross out numbers, okay, to find the median, then here, median is Q2. Towards the left, we have Q1, the 25%, so the lower quartile. This equals to 3. So what you do is you only look at the section from 1 through 6, so the bracketed section, that's to the left of the mean, and you calculate the same thing again, so you do the crossing out from left and right equally, and you end up with the number 3 in the middle. You do the exact same thing to the right-hand side of the mean, and that's Q3. That equals to 8. So as you can see, once you cross out 7 and 9, and then another 7 and 9, and then as long as you converge towards the center, do you see how the middle number is 8? So IQR is Q3 minus Q1, so that gives us 8 minus 3. And so our interquartile range is 5. So interquartile range and range, do you see how it differs greatly? In order to use box plots, so we use the exact same data set. Box plots are called box and whisker plots also. You include minimum value, lower quartile, median, which is the Q2, the one in between the Q1 and Q3, and the maximum value. So say you have a line, right? A graduated, so it gives us increments. You plot our lower quartile, which we said was 3, so your endpoint of your box is 3. Your median, which was 6, so you plot your right hand maximum at 6. So that essentially makes your box. In order to include the upper quartile, you draw another box between the median and the Q3. So the median was 6 and the upper quartile was 8. So you draw another box. This gives us the interquartile range. We include the minimum value. Minimum value is 1, as you can see, and the maximum is 9, right? So we draw from 3 to 1, just a line, like a whisker, and from 8, which was our upper quartile, to our maximum number, which is 9. And this gives us the box and whisker plot. This is important because, as you can see, the middle, the line that cuts in between the two rectangles, that tells us the median. The left line gives us the number for the lower quartile. The right line gives us a number for the upper quartile. And then you have 2 horizontal lines, and these 2 horizontal lines, the endpoints of them give us the minimum and the maximum. So that's a way of graphically representing our data set.